question number 3. The curve with the equation y equals x to the power of 4 plus 3x squared plus 2 is here. We've got points A and B which have these coordinates, and what we want to do is find the equation of the tangent at point A. So the tangent is this line here which just touches the curve at point A. So we need to find the equation of the blue line. Because we're talking about the equation of the tangent of a curve, the first thing we need to do is differentiate. So dy by dx, we differentiate this, so this becomes 4 comes to the front, x, and then reduce the power by 1. 2 times 3 is 6, x, reduce the power by 1, so it becomes 6x to the power 1, I won't write that. And 2 is a constant, so that will just disappear. So dy by dx is equal to this. We need to find the gradient of this tangent before we can find the equation of the tangent. So the way we find the gradient is we substitute in the x coordinate, which we know is -1. So when x equals -1, dy by dx is equal to 4 times -1 cubed plus 6 times -1. So that's -1 cubed is -1 times 4 is -4, and then 6 times -1 is -6. So that's -10. And that looks reasonable because it is going downwards, so we know it's going to be negative. So the gradient of this line, this blue line, is going to be -10. So m equals -10. We also know one of the coordinates, we know point A. So it passes through the x coordinate of -1 and the y coordinate of 6. So we can call this x1 and y1. So we can now use the equation y minus y1 equals m bracket x minus x1. So this will be y minus 6 equals m, which is -10, times x minus -1. So that's -10 times x plus 1, because the minus and the minus makes a plus. So we need to find the equation, so I would multiply this out next. So y minus 6 is equal to -10x minus 10. And finally I just move the 6 across. So we get y equals -10x minus 10 plus the 6 gives you -4. So this is how you find the equation of the tangent at point A, and that's worth 4 marks. So now let's go through the mark allocation for this question. So firstly we have to differentiate. So we'll get 1 mark for differentiating that correctly, and you'll get a 2nd mark for differentiating that one. Then we have to substitute in x equals -1, and we did so and got -10 as the gradient. That will get you your 3rd mark. And then finally your 4th mark was to find out the equation. So we substituted all of them in, and we got down to this equation here. That will get you your 4th and final mark for this question. So part B is asking us to find the integral between 2 and -1 of the curve. So this curve here. And this is worth 5 marks. So let's start by integrating. So I always do a square bracket when I integrate. So when we integrate x to the 4, we add 1 to the power and divide by the new power. So x to the 5 over 5 plus, and then it's 3x, add 1 to the power is 3 divided by 3. And the integral of 2 is just 2x. And since this is definite integration, we don't need to write plus c. So we'll close the square bracket and then we'll put our limits on the outside, 2 and -1. I'm just going to simplify this now. So I'm happy with x to the 5 over 5. But here the 3's will cancel out, leaving you with just x cubed plus 2x. So now let's substitute in our limits. So first of all we substitute in 2. So 2 to the power of 5 divided by 5 plus 2 cubed plus 2 times 2. That's with the 2. Next let's substitute in the -1. So it's -1. Make sure you use brackets with minuses to avoid any sign errors. Divided by 5 plus -1 cubed plus 2 times minus 1. So let's slowly tidy this up. 2 to the power of 5 is 32 divided by 5, so it's 32 over 5. 2 cubed is 8. 2 times 2 is 4. Take away. Minus 1 to the power of 5 is minus 1 over 5. Minus 1 cubed is minus 1, and that's minus 2. Now let's get rid of the brackets. So I'll copy out the first bracket exactly as it is, 32 over 5, and then plus 8 plus 4. And then it's going to be minus 1/5, so that's going to be plus 1/5. Minus 1, so plus 1, and minus 2, so plus 2. So let's tidy up the numbers first. So 8 add 4 is 12, add 1 is 13, add 2 is 15. And we've got 32 over 5 plus 1 over 5, which is 33 over 5. So 33 over 5 and 15. So we can write this as a fraction. So to write 15 as a fraction, the denominator would have to be 5. So 15 times 5 is 75 over 5 plus 33 over 5. And then if we add 75 and 33, we get 108 over 5. And that's your final answer. So let's go through the mark allocation for this question. Now the first thing we have to do is integrate. Now you would get your first mark for integrating at least 2 of these 3 terms correctly. So there you'd get your first mark, and then we integrated all of them correctly, so we'll get a second mark. Then we need to realise that we need to sub in the limits of 2 and 1 and subtract them. That we did over here. So that's our third mark. And then we simplified our terms, so that gave us this line here. That will give us our fourth mark, and then our fifth and final mark would be the 108 over 5. There. So part C is calculate the area of the shaded region here, the bit that's shaded in green. Now, if we just take a look back at part B, we worked out the integral of this, and the integral of this was 108 over 5, which is 21.6 as a decimal. What we worked out is the area underneath the curve between the points of 2 and minus 1. So I'm just going to shade this part in blue. So the blue area is 21.6. We need to find the green area. Now if you look at the green area and the blue area, we have a trapezium. We want to work out the area of the trapezium. So let's start by working out the area of the trapezium. The general formula for the area of a trapezium is A plus B divided by 2 times H. Now A in this case is this length here, which we know is 6, and B is here, which we know is 30, and H is actually your width. So this is from minus 1, and this is to 2, so between minus 1 and 2, so that's 3. So if we substitute these numbers in here, we have 6 plus 30 divided by 2 times H, which is 3. So that's 36 divided by 2 is 18, and 18 times 3 is 54. So the area of the whole trapezium is 54. So we want to work out the area of the green part. So the area of the green region is equal to the whole area, which is 54, minus the area of the blue region, which is 21.6. So this is equal to 32.4. So let's go through the mark allocation for this question. It was worth 3 marks. Your first mark would be to work out the area of the trapezium as 54. Your second mark would be to realise that you'd need to subtract the 2, so 54 take away 21.6 to work out the answer to the question, and finally you get an answer mark for 32.4.